Welcome to EDU World Space.
All right. So we have question number 23.16 of chapter 23, electric potential. We are given that there are two charges, Q1 and Q2. So Q1 has charge equals to 3 nanocoulomb, means that 3 into 10 to the minus 9 coulomb, and Q2 has 2 nanocoulomb. So this is 2 into 10 to the minus 9 coulomb. We have electron sitting at the midpoint. That means this has 0.25 meter distance, this has 0.25 meter distance. The total distance between those two charges is zero point 0.5 meter. So we have this situation at the beginning. These three particles, or the Q1 electron charge and Q2, are sitting on the same line, just a straight line. So we can draw a straight line here. So we have straight line, and this is electron sitting at the center, and Q2 at the end, and Q1 at this end. So definitely, so electric force will act on this electron, and this electron will move either left or right, depends on the Q1 magnitude charge and Q2 magnitude charge. Since Q1 is higher, that means the force acting on this electron will act higher. So let's say this is F1. So this is the force acting on electron due to Q1, and this is the force F2 acting on electron due to Q2. And we know that force is equals to 1 by 4 pi epsilon naught q1 q2 over r square. This is general formula r cap. R is same, we have 0.25 meter, 0.25 meter, and q1 is this charge which is 3 nanocoulomb, and q2 is 2 nanocoulomb, and electron charge is 1.6 into 10 raised to minus 19 coulomb. So let me write the electron charge too. So we have electron charge is equals to 1.6 10 to the minus 19 coulomb. Since this is negatively charged particle, so they both will attract. But Q1 is higher charge, so the final force, the net force, will act towards this way. So the electron will move from this position to this position, somewhere towards Q1. So the question is, find out the velocity if the particle reaches to the some distance here, and the distance between Q1 and electron remains to be zero point 0.1 meter. So the remaining distance between Q2 and electron will remain to be zero point 0.4 meter, because the total distance between Q1 and Q2 is zero point 0.5 meter. So this is the our initial situation, or the before, and this is the final situation, or the after situation. So particle goes from here to here. So at the beginning, the particle has zero kinetic energy or zero velocity, and it gains some energy here and reaches to this point, and we need to find out the velocity of the particle electron at this position. All right, we have used this two formula here, delta u. Delta u is the change in potential energy, and this is change in kinetic energy. So at the beginning there was no kinetic energy, so this means that d del u equals to kinetic energy, and we know that kinetic energy is equals to half mv square, or half me mass of electron, and v square. So this we have to find out the velocity. The general formula for u is equals to 1 by 4 pi epsilon naught q1 q2 over r. That means this is the potential energy between q1 and q2, and distance between those q1 and q2 is r. So we have two situations here. So we have the force acting on this one between these two, and force acting on this one too. The force acted between Q1 and Q2 here, but we don't need to care about this situation now because the question doesn't ask anything about Q1 and Q2 movement. So we think that Q1 and Q2 doesn't move, and there is no change in potential between before and after situation due to Q1 and Q2 displacement. So because there is no displacement between Q1 and Q2, so we don't care about the delta U between Q1 and Q2. We care about the Q1 and electron and Q2 and electron. So let me mark two circles again between these two. So we have two pairs. So we have two pairs, these two pairs. So we have Q1 electron and Q2 electron. And we will find out the change in potential energy. That change in potential energy will give us the kinetic energy, and that kinetic energy can be used to find out the velocity using this formula. All right. So we have kinetic energy is equals to delta U. Delta U is U final minus U initial. We can take the magnitude, doesn't matter because kinetic energy is always positive. Is always positive. So if you even if you take UI, it's same UI minus UF because sometimes students confuse should I write UF minus UI or UI minus UF. So in this situation, doesn't matter. So we don't care. You can take it anyway and just take the positive value of whatever the calculation is. So delta U magnitude equals to the change in potential energy, and we have UF minus UI. So let's write UF, the final one. Okay, coming back to the situation. So we have U final this one. So this is the final situation. So Q1, Q2, these are the pairs. Now the distance between Q1 and E is zero point 0.1 meter and Q2 and E is zero point 0.4 meter. So using this formula, we write it again. So this becomes 1 by 4 pi epsilon naught Q1 minus E over zero point 0.1 meter plus 1 by 4 pi epsilon naught Q2 minus E over zero point 0.4 meter. 1 by 4 pi epsilon naught. Q1 is your 3 nanocoulomb charge. So 3 into 10 to the minus 9. Let's take the minus out. And this is 1.6 into 10 to the minus 19. 0.1. This is also minus coming out. So this becomes 1 by 4 pi epsilon naught. 2 nanocoulomb. 10 to the minus 9. So this becomes 1.6 into 10 to the minus 19 coulomb over distance 0.4 meter. So we have minus taking common out 9 into 10 to the power 9. This we can also take common out 1 by 4 pi epsilon naught. We can take this common out also 1.6 into 10 to the minus 19. So this becomes 3 over zero point 0.1 plus 2 over zero point 0.4. We can take the 10 to the minus 9 common out 2. So that's here. So using the calculator, we can find out the value. We can leave the situation here as follows because we can use directly the UI and take the subtract and find out the delta K. So now we will find out the UI now. So UI now will become this one. So the distance is same. So UI is again 1 by 4 pi epsilon naught Q1 minus E, distance is 0.25 meter plus 1 by 4 pi epsilon naught Q2 minus E over 0.25 meter. So this gives us 9 into 10 raised to power 9. Taking the minus common out, multiplied 1.6 into 10 raised to power minus 19 coulomb. So we have taking the common out 0.25 and adding Q1 and Q2. Q1 plus Q2. Alright, so this is our U1, UI, and this is our UF. Alright, so we have delta K or K equals to delta U magnitude. Taking the difference, so we have 5.04 into 10 raised to power minus 17 minus 2.88 into 10 raised to power minus 17 joule. joule. So we just calculated delta U. So these are the values of UF and UI. That's it. So this is K. K is half m e v square. So putting this value, we have plus 5.04 into 10 raised to minus 17 minus 2.88 into 10 raised to minus 17 joule. So my V becomes root under 2 over me. Mass of the per electron is 9.11 into 10 raised to power minus 31 into 5.04 minus 2.88 into 10 raised to power minus 17. All right, and this is an SI unit, so we have meter per second. So you can use the calculator to find out the value of the V. This is very easy calculations here. All right, so V comes out to be 6.89 into 10 raised to power 6 meter per second. So that's the velocity of the electron when it reaches to the final situation. So we have, let's coming back again. Let me summarize it. We have Q1, Q2, we have electron charge, we have mass of the electron. This is the before situation and this is the final situation. We can use this formula delta U to find out the delta K. E and delta K is just a change in kinetic energy which is equals to half mv square because that the particle was at rest at this position. And we can use this general formula of the U to find out the potential energy of the electron. So we have find out the final one. We don't take the contribution of the electron Q1 and Q2 combination because the Q1 Q2 doesn't move, so that they will cancel down. So UF minus UI, after calculating UF minus UI, we have this value. We take the magnitude because it doesn't matter if we take the UI minus UF or UF minus UI, it's the same value, taking the magnitude. So we have higher value minus lower value. So we have taken the under root here using this equation, and it gives us 6.89 to 10 to the power 6 meter per second. So that's your answer for this question. Thank you.